Bismillahirrahmanirrahim. Subtopic 7.4 System of linear equations with three variables. Okay, at the end of this lesson, student should able write a system of linear equations in the form of ax equal to b and solve it this one by using inverse matrix. Linear system of metric equations. Consider the system of linear equations with three unknown x1, x2, and x3, or maybe use x, y, and z. Okay, this is the system of linear equations. All the linear system above can be written as a single metric equation as below. Okay, all the coefficients become matrix 3 by 3 entries. All the three unknown become the column matrix x1, x2, and x3, and the value on the right hand side become the column matrix b1, b2, and b3. So this is our system linear single metric equations. Okay, with a as the coefficients, x as the unknown, and b as the value on the right hand side. Thus, the system of linear equations can be written as ax equals to b. Okay, question A. -5, 2, 6, and -2. Here multiply by the unknown, we have x and y, and matrix of b we have 22 and 0. Here this is the system linear of metric equations, and for b we have 3 equations. All the coefficients we have 3, 1, and 2. For the second equation, we have 3, 2, and 2. And third equation, we have 1. We don't have x2, means that 0 and 1. All the unknown, x1, x2, and x3. Here's the value on the right side. That this matrix B 11, 10, and 5. Okay, using the inverse method in solving system of linear equations. Okay, the system has a unique solutions if the number of equations in a system equal to the number of variables, and the coefficient matrix has an inverse. Okay, let's say we have ax equals to b. Okay, by solving this ax equal to b, at the end we have the value of x is equal to a inverse times b. So in order to get this one, okay, we need to eliminate a on the left hand side by multiplying with a inverse. So we have ax equals to b. So in order to eliminate a in the left hand of x, we need to multiply a inverse on the left of a. Due to we multiplying this one on the left hand side, this one should be the same. A inverse times A become identity. times x equals to A inverse B. A inverse times x equal to x equals to x. So therefore equal to A inverse times B. Okay, this is the proof. How we get x equal to A inverse times B. Okay, you have to remember, in order to find the inverse of A, we can use these two methods, adjoint method or properties that we already learned before this. Okay, example 2. Okay, solve the following equations by using the inverse matrix method. Here the solutions convert to a matrix equations in form of Ax equals to B. Okay, so this is A, this one is X, and this one is B. In order to eliminate A on the left hand side, that we need to multiply by A both sides. Okay, A inverse times A is identity. So therefore, X is equal to A inverse B. Okay, thus we need to find the inverse matrix by using either one. Okay, by using the inverse method, you have to find the inverse by using adjoint or maybe properties. Okay, so you have to calculate this one first before we can apply this formula. So you have to find this one. We need to find the determinant first. And you have to find this one. We need to find the adjoint matrix first before we can apply this inverse formula. After we have these two values, adjoint and determinant, so we can substitute into inverse formula. Okay, and then this is you have to find these two components first before you can apply this formula. Okay, so equal to this one. This is our inverse. Okay, in order to find the solution, the value of x, we need to substitute this inverse into this one, A inverse times B. Okay, this is the inverse, this is the value of B, matrix of B, and then so by multiplying right hand sided, so we can get x1, x2, x3 equal to 2, -1, and 3. Then don't forget to make the conclusions, because the answer we need to put in the form of conclusions. X1 equal to 2, x2 equal to -1, and x3 equal to 3. Third example, we have A, we have B, both are matrix. You need to multiply A and B and then find the A inverse. Okay, this one means you have to apply the properties. Example 2, just now you need to apply the adjoint method in order to find the inverse. Hence, following this system, A times B. Okay, multiply between these two, so you can get 16. Okay, you can get this one, supposed to be this one, 16 0 0 0 16 0 0 0 and 16 by factorize 16. So we have this one is matrix identity, so therefore AB equal to 16i. Okay, from that one, AB equal to Ki, K is 16. Okay, so we need to find the A inverse by multiplying both sides with A inverse. So we can get B equal to 16i. So A inverse equal to 1 over 16 times B, or B times divided by 16. Okay, by substitute matrix of B into this form, so you can get the inverse of A. Next, hence, so this is the linear equations, and in the matrix form. Okay, just now we already know this one is equal to matrix of A, but with different column and row. This one is the transpositions of A. Okay, this one is A transpose X equals to B. Okay, A transpose X equal to B. So we need to use B because we already have matrix B in the question, so we cannot use B anymore. Okay, so by using the transposition properties, A transpose inverse, so you have to multiply. In order to eliminate A transpose on the left sided, we need to multiply with its transpose. So simply the right hand sided, due to multiply with A inverse in A transpose inverse on the left hand sided, must do the same thing for the right hand sided. So therefore X equal to A transpose inverse equal times P. A transpose inverse is equal to these things. Okay, you have to remember that A transpose inverse, properties of transposition and inverse, is equal to A inverse transpose. Okay, this one. Okay, by substitute the inverse. Okay, so we can get the inverse of the solutions of X is equal to 1, Y equal to 1, and Z is also equal to 1. Example 4. Okay, so this kind of matrix and statement. Okay, this one also properties. This is the solutions. A square minus 6a plus 11i. Now substituting is with the matrix. A square is A times A minus 6a plus 11i. So we have to do this multiplication operations first. Okay, this one. So we can get after that 81, 5, 10, negative 2, 6, 10, 84, 4, and 9, and with the rest. And then we have to do the summations and subtraction operation for the same positions of the entry. So okay, so this is the answer. Okay, next, the question one, you need to show the statement times A equal to 6i. So by substitute answer from that we have before for A square by 6a plus 11i, and then multiply with matrix A. Okay, that's we get 6 0 0 0 6 0 0 0 6. So then we factorize 6 from that matrix. So you can get something like this, and so we have 6 identity. So we have shown the statement. Okay, so let's say next question on way to deduce the A inverse. So from A square minus 6A plus 11I, let it be equal to a B. Okay, so we have A times B equal to 6I. So we have A inverse A times B equal to 6 A inverse. So therefore we have the inverse of A is equal to 1/6 times B. By substitute B is square minus 6A plus 11I, we have the matrix, that matrix before. Now that is 4, -2 and 2, -1, 5 and -2. So -2, -2 and 2. Okay, by multiply this thing, so we can get, by dividing all the entries with 6, so we have 2/3, -1/3, 1/3, -1/3, 5/6, -1/3, -1/3, -1/3, and 1/3. Okay, this is the inverse of A. Okay, example 5. Given A and B, find BA, hence determine the value of P, Q, and R. Okay, let's see the solutions. So we have to multiply A and B. Okay, the question will be to multiply B times A. So therefore we have matrix, okay, 3B1 and -1, and then we have -3, -1 and 2, then we have 5, 2 and 1. Multiply with A. Here we have -5, -3 and 1, 13, 8 and -3. So last column we have -1, -1 and 0. So by multiplying these two matrices, so we can get -1, 0, 0, 0, -1, 0, and 0, 0, -1. And that is equal to, by factorize negative, so 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's matrix equal to I identity. So therefore we have BA is equal to I identity. So in order to find the inverse of A, so we have to multiply this thing with A inverse. BA times A inverse to -I times A inverse. A -I times A inverse. Okay, so therefore this one you have -A inverse times A inverse times A is ID. So therefore A inverse equal to -D. So we put this one. A times PQR equal to negative 12, negative 3, and 19. So, in order to eliminate this negative A in the left hand side, we have to multiply by A inverse both sides. So, P, Q, and R equal to A inverse times matrix negative 12, negative 3, and 19. Okay, so A inverse times A is identity. Identity times PQR, so we have PQR on the left hand side, and then we have to substitute A matrix A inverse equal to negative B. Okay, so by substitute A with inverse is negative B, so we have 3, 1, negative 1, negative 3, negative 1, and 2. So 5, 2, and 1. Okay, so negative 12, negative 3, and 19. So by multiplying the left hand side, this is the right hand side, so we can get 68, 68, negative 29, and negative 25. Okay, so therefore P is negative 68, Q is negative 29, and R is negative 25. This is the answer. Okay, conclusions is the proving how to solve of matrix equations by using properties. A equal to A inverse times C. Okay, exercise, you can try